Good morning students. Today I would like to explain about the mechanisms that is related to chemical reactions of benzene. So chemical reactions of benzene. So normally in case of alkenes or alkynes, they are aliphatic hydrocarbons. They contain unsaturation, the presence of double bond. For example, in case of CH2 double bond CH2, ethene, it's an unsaturated compound, but it's an aliphatic. Or ethylene, like alkynes also, they contain double bond, that is triple bond, presence of unsaturation. These molecules generally, the aliphatic unsaturated hydrocarbons, they are generally participating in addition reactions. But in this case, benzene also contain unsaturation, presence of double bond, but the benzene is undergoing a substitution reaction. Instead of addition reaction, it is undergoing a substitution reaction. As a result of this one, that substitution is retaining the stability of the benzene. Benzene is having resonance stabilization. That is due to only because of electrophilic substitution. If benzene is undergoing a addition reaction, benzene lost his stability. If the benzene is undergoing addition reaction, actually presence of double here, the benzene contains unsaturation, right? So presence of unsaturation, this molecule has to participate in addition reaction, but benzene is participating in substitution reaction. That substitution reaction is retaining the molecule stability. So that is the case. We will see the orientation reactivity of benzene in further classes. Now let us see the chemical reactions of benzene. For example, the benzene is undergoing a nitration. So the general reaction is when benzene, we can represent the benzene like that, or we can also represent the benzene. This is the delocalization of the pi electrons plus H2SO4 in the presence of H2SO4 and HNO3 nitric acid. Benzene is undergoing nitration. Formation of nitrobenzene takes place. This is the general reaction. Formation of nitrobenzene. So when benzene is in the presence of nitric acid mixture, that is H2SO4 and HNO3, it is undergoing nitration and formation of nitrobenzene takes place. Now we will see the general mechanism how this nitrobenzene is formed. The first of all, this benzene is undergoing electrophilic substitution reactions. What kind of reactions here? The benzene is involving electrophilic substitution. Electrophilic substitution reactions. Benzene is undergoing electrophilic substitution reaction. Benzene is undergoing electrophilic substitution reaction. So this is substitution, electrophilic substitution. How this electrophilic substitution is happening? See here, the first of all, the mechanism is separated into three steps. In the first step, electrophilic substitution, right? So we need the electrophile. So we should produce the electrophile. The first step is generation of electrophile. How the electrophile is generated? So H2SO4 and HNO3, these two molecules, when we combine, here nitronium ion is produced. This is the electrophile. Nitronium ion, this is the nitronium ion. This is the nitration mixture, H2SO4 and HNO3. Here the sulfur has 3 oxygens, electron withdrawing more electron negative oxygen atoms attached to the sulfur, and here the hydrogen attached to the oxygen is acidic in nature. This hydrogen is, the bond between the oxygen and hydrogen is broken, and the hydrogen liberated as a proton. H2SO4 is a acid, and it is liberating the proton H. That liberated proton will attaches to the hydroxyl group of nitric acid. Because oxygen has two lone pair, with this lone pair, one of the lone pair is utilized to make a bond with the hydrogen atom. So new bond is formed between the oxygen and hydrogen. So the bond between the oxygen and hydrogen is broken, and that liberated proton will get attached to the oxygen of this HNO3, and here finally HSO4. This is the HSO4 plus we have HNO3, H2NO3. And here what happened? Oxygen utilized this lone pair of electron, right? And here this oxygen is now unstable. Oxygen carrying positive charge, and due to this positive charge, oxygen is withdrawing electrons from the nitrogen atom. Now the bond between the nitrogen and oxygen is broken, and the electrons again taken by the oxygen atom. That lone pair of electron, whatever the lone pair of electron, it is utilized to make a bond with the hydrogen atom. That lone pair of electrons are now taken by the oxygen atom from the nitrogen. Now the bond between the nitrogen and oxygen is broken. That pair of electrons are taken by the oxygen atom. Oxygen is now this molecule eliminated as a water, and formation of nitronium ion takes place. Now the bond, see here, this lone pair of oxygen has a negative charge. These electrons are shifting from here to here between the nitrogen and oxygen. Formation of double bond takes place between the nitrogen and the oxygen. Anyway, nitrogen has positive charge. Nitrogen has positive charge. Now, this nitronium ion acts as a electrophile. Now, this is electrophile. This is the generation. This is the electrophile generated. Electrophile is generated. Now, the generated electrophile, now it is attacking benzene. Now, it is attack of benzene. This electrophile, now NO2 plus is attacking the benzene. Now see, normally in benzene is undergoing resonance, and it is producing certain hybrid structures. And this is the pair of electron, this is the pi electrons, and these pi electrons are shifting. This total 6 electrons are mutually shared by the 6 carbon atom, and every time each carbon, when the electrons are shifting from this carbon to this carbon is getting a octet. When these electrons are shifting from here to here, this carbon is getting octet. Like that, every 6 carbon, all the 6 carbons in the benzene is getting the octet. And its stability, due to this resonance, the benzene is more stabilized. Actually, each carbon, in order to get the octet, every carbon atom must have 8 electrons. But here, only these 6 electrons are sufficient to only 3 carbons. Actually, if every carbon has to get an octet, every carbon need 8 electrons. These 6 electrons are only sufficient for only 3 carbon atoms. Only 3 carbon atoms are, if these 6 electrons are shared by the only 3 carbon atoms, so 3 carbon atoms are getting octet. Remaining 3 carbon atoms are not getting octet, because these 3 carbons are only have 6 electrons. Because, see, this is the carbon atom. For example, see benzene. So benzene has a hydrogen atoms, 6 hydrogen atoms. Every carbon has 6 electrons, right? These 2 electrons and this is 2 electrons. We are talking about this carbon. These are the 2 electrons and this is 2 electrons, and remaining 2 electrons are with hydrogen. Total, this carbon has 6 electrons. Like that, every carbon has 6 electrons. But now we are placing 3 double bonds. And each double bond carries 2 electrons, right? Now like that 6 electrons are only sufficient. See, this carbon atom has 6 electrons. If I have given 2 electrons to this carbon, and this carbon is also has only 6 electrons, and I have given 2 electrons to this carbon, and this carbon also has 6 electrons, and I have given 2 electrons. So now the 3 double bonds, this is 1 double bond, 1 double bond, 1 double bond. So that is the 3 double bonds finished. The electrons are taken by these 3 carbon atoms. What about the remaining 3 carbons? These 3 carbons has only 6 electrons. But here generally that is not happens in benzene. This carbon atom, the 6 electrons are mutually shared by the 6 electrons are mutually shared by the every carbon atom. So sometimes this carbon get octet, sometimes this carbon get octet, and every carbon, due to this delocalization, this is called as delocalization. Due to this delocalization of pi electron, every carbon atom is getting octet, and due to this every carbon is getting octet. Due to this, the benzene is more stabilized. So that's why here, for example, we have seen the rotation when these pi electrons are shifting from this carbon to only to this carbon. Actually, these 2 pi electrons are shared between these 2 carbons. But now these 2 carbons are shifted towards this carbon. So now this carbon is getting an octet because already this carbon has 6 electrons plus these 2 8 electrons. Anyway, now when these electrons are moving, this is the delocalization, right? Electrons should not stay in one position. They are delocalizing. Now these electrons are shifting from here to here between this carbon and this carbon. What happened? If these electrons are shifting from here to here, these electrons has to shift from here to here because, for example, if these 2 electrons are shifted from between this carbon and this carbon, what is the valency? What is the valency of this carbon atom? 1, 2, 3, 4, 5. So that's why the density of the electrons is more and more at this carbon atom. So that's why what happened? So listen carefully. When these carbon atoms are shifting between these 2 carbon atoms, this pi electron has to shift from here to here. If these 2 electrons are staying in this position, so what is the density? What is the density of this carbon? 1, 2, 3, 4, 5. It is unstable. So that's why this carbon is pushing electrons towards this carbon atom, and these electrons are moving towards this carbon atom. So now the electrons shifted. These electrons are shifting from between this carbon and this carbon, between second and third carbon, and the electrons between the third and fourth carbon is shifting towards the fourth carbon, right? And now these electrons are shifting from here to here. Again, the electrons, for example, I have given numbering 1, 2, 3, 4, 5, 6. When the electrons of fourth and fifth carbons are shifting towards the fifth carbon, the electron of fifth carbon should shift towards the sixth carbon, because when this, see, listen carefully, the electrons actually now they are on the fourth carbon. Now at present electrons are there on fourth carbon. When these electrons are trying to shift, trying to move, the density is trying to move between the fourth and fifth carbons. Here already the density is there on fifth carbon. If this density is also moving between the fourth and fifth, already the fifth carbon has some density. So this is overloading. That's why the fifth carbon is shifting its electron towards the sixth carbon. So like that, now these 2 electrons are shifting from fourth to fifth, and the electrons, whatever the electrons previously there between the fifth and sixth, that electrons are shifting from towards the sixth carbon. So like that, these electrons are mutually shared by the, now these 2 electrons are shifting from sixth to 1. Between the 6 to 1, the electrons are shared. This cycle happens repeatedly. Like that, benzene is getting a resonance stabilization. Now see, this is the initial structure and this is the final structure. We explained in the first class, benzene has 2 resonating structures. That is the position of the double bond may vary. See here, the position of the double bond. Here the double bond is there in this position, but the double bond is there like that in this position. Only we can write only 2 resonating structures for the benzene. So like that, this is the electron delocalization in benzene. So we are getting 2 hybrid structures. That is the rotation of the electrons. Anyway, now After that, attack of electrophile. Now this electrophile is attacking, because see, we can see here, this is the positive charge. The negative charge is appearing on the carbon, some carbons. Here the negative charge is appeared in this case, and here also negative charge, and here also negative charge. In the benzene, totally in the ortho position and para position, we are getting the negative charge. See, this is the ortho position, and this is the para position. This is also para position. So total ortho and para positions are getting negative charge. So that's why benzene acts as a, in generally acid base. If you talk about acid base reaction, in that case also one is acting as an acid, another one is acting as a base. Here also benzene acts as a base because benzene rich of electrons. It acts as a rich of electrons because this ortho and para positions we are getting the negative charge, right? Here negative charge, here negative charge, and here negative charge. And ortho and para positions are showing electron density, more electron density. In benzene, ortho and para positions are showing more electron density. So that's why here this NO2 group, nitronium ion, will try to attack and at this position or this position or this position, anything, at any position. Because so for example, for our convenience, for example, nitrogen attacked on this carbon, because when this pair of electrons are shifted from here to here, second carbon is getting a negative charge, and this positive charge NO2 attaches to the second carbon. Yes, sir. And every carbon has one hydrogen atom. That is, we hide it. Every carbon has one hydrogen atom. We are hiding that hydrogens because that is, if you write like that, you may confuse. That's why we hide it. Every carbon atom has one electron. Anyway, now when NO2 attaches to the second carbon, now again the shifting takes place. We know that is the bond shifting takes place here. This bond shifted from here to here, and this bond shifted from here to here. Like that, shifting takes place. And finally, the two bonds appear at these positions. And what happened in the final structure? Finally, the NO2 group, the hydrogen atom between the carbon and hydrogen, the bond between the carbon and hydrogen broken. That electrons are shifted between the second and the third carbon. And finally, this is the formation of product. Between the carbon and hydrogen, the bond between the carbon and hydrogen broken, and that electrons are shifting between the second and the third carbon. Again, we are getting the double bond. So this is the first step is generation of electrophile, and after that attack of electrophile, and next one is formation of product or elimination of hydrogen atom. Anyone, formation of product or elimination of hydrogen atom. So this is the mechanism of electrophilic substitution mechanism in benzene.